Let's see how we can solve several problems on factor and polynomials. So this is our first problem. We're trying to factor x cubed minus x squared plus 2x minus 2. This problem will be easier to look at if we split the terms into pairs. So we just put parentheses around the first two terms, x cubed minus x squared and 2x minus 2. Then we try to factor out a common factor out of these parentheses. So there is x squared in both of those terms. So we should be able to factor out x squared. Likewise here, 2 is present in both of the terms. So we should take that out. So we're looking on x squared times x minus 1 plus 2 times x minus 1. So now we're going to treat this x minus 1 as a common factor and factor that out. So we're looking on x minus 1 multiplied by x squared plus 2. So this x squared comes here, and this plus 2 comes there. And that would be the factorization. Then we have yet another problem, x squared minus 100. So we can recognize it as x squared minus 10 squared. So it's a difference of two squares, so it boils down to x minus 10 times x plus 10. Then 9x squared minus 25y squared, well, we can as well recognize it as 3x, all of that squared, minus 5y, all of that squared, and that results in 3x minus 5y multiplied by 3x plus 5y. Then in problem 4, we're looking on x to the 4th minus 16. We can start by recognizing it as x squared, all of that squared, minus 4 squared. So by the difference of the squares formula, we get x squared minus 4 multiplied by x squared plus 4. But then we should have another look on this term, which is x squared minus 4. And see that this is a difference of squares in its own right, so we can as well split it into x minus 2 times x plus 2 multiplied by x squared plus 4. That's the maximum possible factorization of this polynomial. Then on to this fifth example, x squared minus 14x plus 49. So this is actually a perfect square, because this is x squared minus twice the cross product plus 7 squared. So it's x squared minus 2 times 7x plus 7 squared, so it came from x minus 7 squared. Likewise, this example, 25x squared plus 10 plus 1 is the same as 5x, all of that squared, plus 2 times 5x times 1 plus 1 squared. So this, we have square of the first, square of the last, and twice the product of two terms. That must be the square of 5x plus 1. Then x cubed plus 27, that's the sum of two cubes. That's x cubed plus 3 cubed. So by the formula for the sum of two cubes, this is the same as x plus 3 times x squared minus 3x plus 3 squared, which is the same as x plus 3 times x squared minus 3x plus 9. And in problem 8, we're looking on x cubed minus 8. This is x cubed minus 2 cubed, and by the difference of the cubes formula, we're looking on x minus 2 multiplied by x squared plus 2x plus 2 squared, which gives us x minus 2 multiplied by x squared plus 2x plus 4. And in problem 9, we have this x squared plus 5x plus 6 polynomial. So unlike a problem in problem 5, see that 6 is not a square of something, so it's probably not gonna be a perfect square. So we're gonna try to split it into two parentheses, so we can x plus something and times x plus something. So I want to split 6 into two factors so that their sum is 5. and x plus 2 times x plus 3 actually works out. In problem 10, we're looking at x squared minus 2x minus 15. So see that 15 again is not a perfect square, so it's probably not going to be a square of the difference or a square of the sum. So try to work it into two parentheses. And we need to split negative 15 into two factors so that their sum is negative 2. So to get negative 15, we need to have one positive, one negative number. That's why I have x minus x plus. And, well, so we need to get negative 2 for the sum, so it looks like x minus 5, x plus 3 is a good choice in this case. And that actually works out. When you FOIL this expression, you do get the x squared minus 2x minus 15 back.